All right, so my name is Maxim Koretsky, and I also go by the name NgWizard. This is here. And I started Angular in Depth Medium publication. This is the place where you can find explanations for the most challenging Angular topics. We're close to reaching our first 1 million views, so I recommend going and checking it out. I'm also one of the top contributors on Stack Overflow for Angular, and hence I have to take a deep look at Angular sources. But what happens is occasionally I find them completely changed. And so this is me when I discovered that they rewrote View engine entirely. Well, today I'll be talking to you about DOM manipulations in Angular. And we all do DOM manipulations in Angular. Why do we need to talk about that, right? How is that different in Angular? The thing is that Angular was designed to run on multiple platforms. We have web workers, it can run on the server side. So naturally, an extra layer of abstractions was introduced on top of the pure DOM. These abstractions, Implementating, ViewContainers, all the other stuff that most of us don't know. And we need to take a close look at these abstractions today. So we'll talk about 3 things. First, we'll start with the correct approach to working with DOM in Angular, using custom directives and data binding mechanism. Then we'll take a close look at the tools the framework provides for us to do that, specifically ViewContainers and Renderer service. And along the way, we'll get familiar with some of the internal parts of the framework. This is actually my favorite part. We'll take a look at the rendering engine and view layer engine. Okay, let's start with the correct approach. So any Angular application has presentation logic and rendering logic. What is the difference between the two? Well, presentation logic defines how business data should be presented to a user. To give you an example, you can have a set of tasks, and then you want some tasks shown on the left column and other tasks, for example, completed tasks, shown on the right column. So this would be an example of the presentation logic. You define 2 arrays and then assign each array to a respective column. Now, rendering logic uses this information to actually show the data on the screen. So it works with the DOM. It arranges DOM nodes in a particular order, applies styles to them, and you can see these tasks on the screen. So given an example with the tasks, this would be an example of rendering logic. We create DOM nodes for each task item, and we add it to the DOM. Okay, the question is, we have 2 types of logic. Where should we put this logic in Angular? Well, presentation logic goes into components. We should view a component as a container with presentation-specific data. There is a good phrase, component state. You probably have encountered it before. I will be using a lot this phrase today. Where do we put rendering logic in Angular? We have an extra layer between components and the DOM, which is directives, right? And this is the place where we should encapsulate rendering logic. The important piece is that we do not put rendering logic into components, okay? And we use data binding mechanism provided by the Angular as a communication channel between components and directives. Okay, so to summarize, when we start thinking about DOM manipulations in Angular, we define presentation logic and rendering logic. We put presentation logic into components, rendering logic into directives, and we use the data binding mechanism to communicate between the 2. Okay, what are the benefits of doing so? Well, we have 2 benefits, at least. First, by separating presentation logic into components, the presentation logic can be reused on platforms with rendering engines other than DOM. Do you know any other platform other than DOM? Mobile devices, right? Very native script. And if we encapsulate all rendering logic into directives, it also can be reused across the application, right? You simply apply directive to any component's template, and you get a code reuse. So this is very, very beneficial. And let's see this approach in action. Angular does not provide a built-in directive to add an attribute. So let's implement such custom directive. right? The name for the directive is addAttribute, and you can see that it has an input binding with the same name. And when a user clicks on a button, we assign a custom attribute name and its value to the bound attribute property. So then, during change detection, the data binding mechanism synchronizes the changes to the directive, and we get an attribute added to the DOM element. So nothing new here for you, I think. What's interesting is that if we take a look how we can implement this directive, specifically, we are interested in the setAttribute usage. And it's a native API method, right? And the question that we should ask ourselves is it safe to use native API inside Angular? Actually, Angular discourages direct DOM access inside the application. Why? The reason is platform dependence. As I said, Angular is a multi-platform framework, right? And we have two non-DOM environments. Inside the web worker, there is no DOM there. Server side, it's not browser, no DOM there. And what do you think will happen if we take the directive that we just implemented and then run it inside the web worker or on the server side? Will there be an error? Well, I've done that to test it, of course. And here are the results. As expected, there is an error inside the web worker. But you see, no error on the server side. Weird, right? Well, it works because universal platform, which is server-side rendering, under the hood uses the library called Domino. And that library implements DOM environment on the server side. So that's why it works. But as you can see, this direct DOM API access can cause problems on other platforms. So we cannot simply use it in our Angular application. And we have tools, right? Angular provides this for us that can make direct DOM access safe on all platforms. I think that you know these tools already. So we will get deep into these tools right now. But before we do so, let's first think what type of DOM operations we perform inside our Angular applications. And I think they can be split into two major categories. The first type of DOM operations that we perform is changing DOM element properties. It's an existing element, we can set an attribute, can change its style, or add a class. The second type is changing DOM hierarchy, right? Creating an element, adding it to the DOM, or removing an existing element from the DOM. And what's interesting is that Angular provides two distinct tools specific to each type of DOM operation. And these tools are the Renderer service and ViewContainers. So if you want to change DOM element properties, you should use the Renderer service. Actually, it's used everywhere inside the framework. If you take a look at the sources, you will see that the platform, the Angular framework itself, uses it everywhere, including built-in directives, ngClass and ngStyle. To change DOM hierarchy, we use templating technique with ViewContainers. And it's used also inside the built-in directives ngIf and ngFor and ngSwitch. Also, if you have read before about them, surely you have, you probably noticed that they are called structural directives. And the word structural simply means that they change the structure of the DOM. Right? This is what this table shows. So these are the main tools you should use when working with DOM in Angular. And let's take a close look at them and start with the Renderer service. So what is this service? Well, it makes direct DOM access safe and provides a low-level API to changing DOM element properties. An example would be setAttribute method. And actually, we can use this method to refactor our directive, where we use direct DOM access, and make the directive code platform independent. Let's do it right now. Just to remind you, this is the approach that is not recommended. And to use the renderer service, we simply inject it into the constructor and then use its setAttribute method to add an attribute to the DOM element. And this is the correct approach to manipulating DOM element properties. Now, this is not it. I've done that, and then I started thinking, okay, but how does Renderer make our code platform independent, right? Under the hood, what is the secret? The simple answer is that the implementation of the renderer is always platform specific. So the universal platform has its own renderer implementation, web worker, its own renderer implementation. But so renderer is not simply a wrapper around native platform API, right? And to find that, I had to dig down into the sources of the universal and web worker platforms, right? This is me trying to do. Okay, and I couldn't really stop until I reverse engineered entire rendering layer. Let's take a close look at it. So the three pieces is all there is to the architecture. And the two main pieces are the DOM adapter and renderers. So what is DOM adapter? DOM adapter serves as a linking layer between the platform, which is in this case is browser, and the framework, which is renderers. Okay, and its implementation is always platform specific as well. So inside the browser, it knows how to communicate to the browser API. On the server side, it knows how to communicate to the Domino library, right? This library that I mentioned before. What is renderer? Well, we've seen that it's used to manipulate DOM element properties, and it communicates to the DOM adapter, uses its API to perform DOM operations. So usually, renderers do not interact directly to the platform API. This is an abstraction that makes our code platform independent. But there is something interesting about renderers. You probably noticed that I'm using plural form when talking about renderers. And this is because there is no one renderer. It's not a singleton. Each component in Angular defines how it wants its view to be rendered, right? It can be rendered using native shadow DOM or emulated. Or we can have no encapsulation at all. So we get 3 view encapsulation modes. And depending on what type of the view encapsulation mode the component defines, Angular will create a specific dedicated renderer for this component. So if a component defines shadow renderer, shadow emulated mode, it gets shadow renderer. If the mode is emulated, it gets emulated renderer. So there is one-to-one relationship between a component and a renderer. And this is one of the reasons why you cannot simply inject a renderer into a standalone service. It would be unclear what type of renderer you need. And every platform has one default renderer, which interacts with the DOM adapter. And all other renderers, we've seen few here, also there is debugging renderer. They all delegate all DOM operations to the default DOM renderer. Okay, so for the curious minds, I have put together a table that demonstrates different DOM, adapter, and renderer implementations on different platforms. And so I have used exact class names. So if you're curious enough, you can download the sources and go find these implementations inside the sources. And some of them are really, really fascinating, particularly web worker renderer. It acts as a relay mechanism. And instead of manipulating the DOM inside the web worker, it simply transmits messages from the web worker to the main UI thread. So it's an engineering genius. You have to take a look at it, definitely. Now, one thing about renderers is that we can see many render implementations here. So can we introduce our custom render implementation? Yes, we can. Imagine you're migrating from AngularJS to Angular, right? And you will have DOM nodes created by both frameworks. And you want to mark DOM nodes created by the Angular framework in some way to distinguish between the two. Adding a class would be one way to do that. So we can use a custom renderer implementation to leverage it and then add a class to every element created by the framework. Let's see how we can do that. Well, to introduce a custom renderer into the application, we simply declare a class that implements all methods defined by the renderer2 interface. You will have many methods here, but right now I'm only focused on the createElement method. And I told you before that there is one default DOM renderer, and it's always a good idea to delegate all DOM operations to this renderer. We don't want to know how we should work with the DOM, because we want to make our custom renderer platform independent. So you can see here that I'm injecting the default renderer into the constructor when creating an instance of a custom renderer. And then I simply use it and delegate all DOM manipulations to it. So we create an element and add a class. So now if you run this code in your application and you inspect the result in HTML, you will see that all DOM elements created by Angular framework has the created by Angular class. This is what we try to achieve. And really, this is very convenient. Okay, so that's it for the renderer service. Again, we identified that it should be used to manipulate DOM element properties. However, there is one interesting thing about it. It has methods to change DOM structure. Methods like createElement, removeElement. And I told you before that you should use templating technique and ViewContainers to do that job. Why can't I use renderer for that? And actually, you do not want to do that. And I will show you right now why. So imagine you have this component with one spawn element inside this component. And then when a user clicks on the remove button inside the remove method, I use the renderer to remove that spawn element from the DOM. Instead of the renderer, I can use native platform API. And this is also something you should not do. Okay, so what's interesting is that if I add the check inside the ngAfterViewChecked lifecycle hook, and then I use the viewChildren query to get the number of spawn elements inside the component view. Just want to know how many of them are inside the component's view. We will get number 1. Well, probably you expected number 0, right? We've removed it from the DOM. Why is it number 1 there? Some of you may think that this is a bug, so you can go and file a GitHub issue. But before you do that, I'll tell you what the problem is. Angular doesn't work with components or the DOM directly. Instead, it uses an underlying representation of a component known as the view. I think some of you may have encountered before. So let's take a look at the view layer specifics in Angular. Every component in Angular is represented as the view. View is a core concept in Angular under the hood. And it's an abstraction that associates DOM nodes defined in a component template, like the spawn element that we just saw, with the component class. It binds it together. Okay? And when Angular creates a component, it first creates the view for that component, and then creates the view nodes and respective corresponding DOM nodes. I think the question you're asking now yourself is, but I define components. How is it turned into the view? Well, here's the simple process, and that's what the compiler is for. You define a component, provide metadata using component decorator, and the template is the main piece of that metadata. So the compiler uses this template and generates the view factory. Who have seen this word before, view factory? Okay, I think anyone who has worked with ahead of time compilation have encountered the view factories. And what is view factory? Why do we need that? Well, short answer is the view factory, you can think of it as an instruction set, defining what type of view nodes and DOM nodes should be created. So for our component, the previous component, there would be one instruction, create spawn element. Okay? And when Angular needs to create a new component, it resolves the view factory for that component and creates the view. So there is one-to-one relationship between a component and its view. And this picture again, what's important is that Angular and all internal parts of the framework, like change detection in particular, they work with the view. And so any changes in the view are reflected in the DOM. And it's a one-way process. There is no backward synchronization from the DOM to the view. And so if you change the structure of the DOM, the structure of the view is not affected. And this is exactly what happened to a spawn element, right? We removed it from the DOM, but it's still inside the view. And so the view children query that I used, it's part of change detection. It runs on the view and detects the spawn node inside the view and reports the number 1 instead of 0. Now, one of the questions that I always get asked is, Max, we wanted to remove that spawn element and we did it. It's not in the DOM anymore. Why should I care that it's inside the view, right? The problem is that this spawn node is not completely removed. It's not inside the DOM, right? But still, there is the view node that holds a reference to it. And that's a possibility of a memory leak. Now imagine you have many, many nodes like this. So it's bad, but things can get even worse. Imagine you had a component instead of simple spawn element. And that component could have its own children. So there would be an entire components tree. And you're thinking that you have removed that component from the DOM, but it's there. And what's worse, the change detection would still run on the entire components tree. Okay, I hope I convinced you that you should not do that. And instead, as I said, we should use templating technique in view containers. Now let's take a look at the view container. So as opposed to the renderer, view container makes DOM hierarchy changes safe. So it works with DOM structure. And it's a simple abstraction in Angular that is used to hold and manipulate the views. How do we create these views? Two methods. We have two methods to do that. First, we can create a view from the view factory. Or sometimes it's also referred to a component factory. And we have a method, create component, that can be used to do that. Usually it's used to create dynamic components, components not found in other components templates. The second type of the view that we can create is called embedded view. And it's created using templates. In Angular, we reference templates using template ref, and it's simply a reference to the compiled template. So we use the method create embedded view to create these type of views. The word embedded, I always, on Stack Overflow, people always ask, why is it embedded? It's because it cannot be standalone. It should always be part of the view container and the component. Okay, so these are the main pieces of the templating technique: view containers and templates. View containers also implement methods that we can use to manipulate the views. We can create the view and then insert it into the view container. We can remove it from the view container, or, very interesting case, move a view between view containers. So let's refactor our original example where we used renderer to remove the spawn element and instead use the templating technique in view containers. Okay, the first thing to do with view containers is to wrap our element that we want to create the view from inside the ng template tag. Okay, and then we need to reference this template ref inside the component, and I'm using viewChild query for that. Right, so this is the first part. The second part is to create the view container. We already have a reference to the template, so we can create the view, but there is nowhere we can insert it, right? There is no view container to hold it. So I'm adding the view container to the component template now. And I'm using ngContainer tag for it. Okay, what's interesting is that any element inside a component's template can act as the view container. But the most common element for that role is ngContainer. It's because it's rendered by the framework as a simple comment. So it doesn't introduce any redundant DOM elements. Okay, now, I have a reference to the template and the view container now. As I said, these are the two main pieces of the templating technique, and now we can create the view and add it to the view container. It can be done as simple as calling one method, create embedded view, and we just pass the template ref to it. If you inspect the result in HTML, you will see that the span element is added to the DOM. Okay? And our task was to remove it from the DOM. So we no longer remove the span element itself. We remove the view that holds that span element. And again, can be done as simple as calling the remove method. We do not pass the index of the method, of the view, so it will remove the last embedded view. We have only one view. So if you inspect the result in HTML now, you will see that the span element is gone. And if we use the same check that we used before using ViewChildren now, and inside the ngAfterView checked lifecycle hook, we log the number of span elements now, we get the expected number 0. Okay, now let's conclude what we've learned. First, when we start thinking about DOM manipulations in Angular, we split all logic into presentation and rendering. We put presentation logic into components, and importantly, we do not implement DOM manipulation scenarios inside the component class. Instead, we use custom directives to do that. But inside these custom directives, we do not use direct DOM access because it's platform, it can cause problems on platforms other than DOM. And instead, we use the renderer service for it, okay, to change DOM element properties. Importantly, we do not use renderer to change DOM structure. And instead, we use the templating technique and view containers to modify the DOM hierarchy. Okay? Now, the last thing. Wise people say that truth lies within. And in case of Angular, it's inside the Angular sources. So do not be afraid to go and read the sources, as I did, and learn the truth. But always remember that nothing stays the same. Thank you very much for your attention, and good luck.
Yeah.